In this part, we're gonna solve this problem and we'll use two ideas. I'll leave one homework and let's try this one. Let's read the problem. It says problem 10. Find the number of functions f of x from 1 to 5 to 1 to 5 that satisfy f of x equals f of x for all x in 1 to 5. Okay, let me write the ideas. If you want to solve this problem, you can pause the video and try first on your own. And after that, you can watch the ideas, then we will solve it together. Idea 1 is what? Permutation graph, something similar to that. Permutation graph. It means what? Permutation graph is not. Let me explain first. Permutation graph is what? For example, suppose pi is a permutation from 1 to 5. It is 2, 3, for example, 4, 1, 5. Then you connect I to pi of I. It means what? For example, you connect pi of 1 is what? Is 2. Look, pi is a function. It is a permutation. First element is, let me move it here. First element is this, second element is this, third element, pi of 4, pi of 5. Pi of I means ith element. Okay, so we connect 1 to 2 because pi of 1 is 2, pi of 2 is 3, 2 to 3, pi of 3 is 4, 4, pi of 4 is 1, and we should connect 5 to 5, okay? And we can prove it is a combination of disjoint cycles or union of disjoint cycles. Here for f of x, we want to draw a graph, for example, 1, 2, 3, 4, 5, and we want to connect I to f of I. Okay, so we define this function, and maybe, for example, if we consider f of i's, it is not permutation. So that's the reason I say it is a special case of permutation graph. Or we can say general form of permutation graph, because for example, maybe if we consider f of 1 is 1, for example, f of 2 is 1, and so on. Okay? So let me tell you an example to see the graph will be what? F of 2 is 1, f of 3, for example, is 5, f of 4 is 2, f of 5 is 2. So here 1 is connected to 1, f of 1, 2 is connected to 1, 3 is connected to 5, 5 is connected to 2, and 4 is connected to 2, okay? It is how we change the function to graph. Okay, idea 1 is this, and we will use this graph for this function. Idea 2 is what? Is casework. And in casework, we consider what? For example, the priority is that we consider the most limited case. Okay. Now use these two ideas to solve the problem. Okay, let me try first on your own for 3 minutes. Okay, so now let's try the rest together. Here, f is from 1 to 5. We want to consider this condition. F of x is f of x. So f of x equals f of x. So we have the two conditions. First, if first case f of x equals x, so then both sides will be x equals x, it will be okay. So one condition is this, second one. Suppose f of x is y, that y is not equal to x. So it means what? X goes to y. Okay. Now again we have two conditions. Y three cases. 2, 1. Y goes to x, or y goes to y, or y goes to third element. Okay. So case 2, 1. F of y is y. Case 2, 2. F of y is x. 2, 3. F of y is equal to z, which z is not x or y. Okay, let's consider these three cases. In this case, we can say x goes to y and y goes to itself. So f of x is what? Is y. F of x will be what? We know f of x is y, f of y is y, and f of y is y again, so it will be okay. So this one works, this one works, this one. X goes to y goes to x. So f of x is what? F of x is y, so it will be f of y is x. F of x is what? F of x is y, f of y is x. And f of x is y. Y is not equal to x, so that's a contradiction. So this case is not good. Third case, suppose f of x, we know f of x is y, and f of y is z. So f of x is what? Is f of y, and f of y is z. Now f of x is what? F of here we've calculated f of x is z. So we can conclude f of z from assumption of the problem should be equal to z. So we have something like this. Okay. So good cases are what? X goes to itself, x goes to y, and y goes to itself, x goes to y goes to z, and z goes to itself. Let me write. This one is okay, or this one, then this one, or this one, then this one. And we know f is from 1 to 5. 2, 1 to 5. The rest is casework. Okay, so try the rest for 5 minutes first on your own. Okay, let's try together. Let me finish this one. Okay, so here I want to calculate number of x's that go to themselves. Okay, so for example, suppose number of elements that, for example, x, that f of x equals to x. It can be from what to what? Maximum is 5. It can be 4, it can be 3, it can be 2, it can be 1. Okay. For 5, we have 5 elements like this: 3, 4, 5. So, one way. For 4, let me tell you, it will be what? For 4, you have 4 elements: 1, 2, 3, 4. And we have one element here that, because we said only this one is acceptable, so it should be connected to one of these 4 elements. So first we say 5 choose 4. We select 4 elements like this, and then the element that is left has 4 choices to be connected to which of them times 4. It will be 5 times 4, 20. For 3. So try to calculate case 3, 2, 1 first on your own. Okay, try to calculate rest on your own for at least 3 minutes. Okay, now let's calculate case 3. We have 3 elements here. Okay. Now, in second row, maybe we have 2 elements here. Maybe 1, 2, 3. We have 1 element here, 1 here. For example, it means like this. This one connected to this. This one is connected to this one. This one is connected to this one. Okay, we have these 2 cases. So it will be what? We can say it is 5 choose 3 for this part times this case. You say, okay, this one has 3 cases, this one has 3 cases, so it will be 3 times 3 plus. Here, we should select which of them is in second row. For example, it is first row, second row. You say 2 choose 1, because 5 choose 3 is also for this one. 5 choose 3, then 2 choose 1. Then this one has 3 cases, and this one has 1 case, okay? So, if we calculate, it will be what? 5 choose 3 is 10, 3 times 3 is 9, 2 times 3 is 6, 9 plus 6, 15 times 10, 150, okay? Now, let's calculate 2. So for case 2, try again case 2 first on your own. Okay, so try this one for at least 3 minutes. Okay, let's try to calculate when we have 2 elements like this, 2 loops, number of loops. So if you have 2 loops, then second row can have 3 elements, or it can have 2 elements. or it can have one element. Okay, so for these parts, let me move all these elements. Okay, first we say 5 choose 2 for our 2 loops. The first one is, for this case, 2 cases, 2 cases, 2 cases, 2 cubed, plus this one will be 3 choose 2 for these 2 elements, then 2 squared for connecting these 2 elements, and this one 2. Next one, 3 choose 1, then this one has 2 cases, and these 2 have 1 case. Okay, so if we calculate this, let's see, it will be what? 5 choose 2 is 10, 2 cubed is 8, 3 times 8, 24, plus 3 times 2, 6, 30, 38, 380. And last case, case 1, if you have one loop. Okay, try to calculate this one again first on your own for at least 3 minutes. Okay, let's try. Okay, if we have one loop, then in second row we have 4 elements, 1, 2, 3, 4. Or let me put it here. Or we can have 3 in second row, 1 in third row. Or we can have 2 in second row, 2 in first row, or we can have 1 in second row, 3 in first row. So we can say 5 choose 1 for this one times. This one will be one case, all of them should be connected to this loop. This one again, one case, but this one has 3 cases. And you should say 4 choose 1. Which element is here? Then times 3. Next one is 4 choose 2 for second row, and one case here, but here 2 squared, plus 4 choose, for example, 1 or 4 choose 3, and one case here, also one case here. Okay, if you calculate, it will be 1, 5 times 1 plus 4 times 3, 12. 1 plus 12 plus 6 times 4, 24. Plus 4. Okay, now 4 plus 24 is 28. 30, 40, 41. So it will be 5 times 41. So 5 times 41 is 205. Okay. Now, if we want to add these numbers, 205, 380, 150, 20, and 1. 1 plus 20, 21. Plus 150, 171. 171, 471, 551. 751, 756. So the answer is 756. Okay, so we've solved this problem by using these two ideas, casework and permutation graph, or graph of this function. Let me tell you one homework. We can solve this problem, homework 1. And instead of this, you can solve it as f of x equals f of x, and instead of 1 to 5, solve it for 1 to n. Okay, so try to solve it for general n. F of x equals f of x. Okay, if you wanted to learn more ideas or 40-50 important ideas in combinatorics, algebra, number theory, or geometry, feel free to send message to my WhatsApp number in the description. Okay.